All right, so are you ready? Because today, we're talking about a telescope that's so unbelievably huge.
Huge. Yeah.
It would make the James Webb look like a toy, like you said.
Was a little speck of dust.
Yeah. We're really diving deep today into this idea of a space telescope, but with a mirror 1 kilometer wide.
1 kilometer.
Yeah, 1 kilometer.
That's like 10 football fields across. I mean,
I can't even.
it's really hard to wrap your mind around something that massive just floating around in space.
That's exactly what I was thinking, too. And we're actually basing this whole deep dive on an article by this physicist, Casey Hanmer.
Okay.
It's called It's Time to Build the Exoplanet Telescope.
Catchy.
And let me tell you, it's a wild ride, this article.
It really is. And the thing that really hooked me is that this isn't just some pie in the sky idea. Like
Okay.
he actually gets into the nitty gritty of how we could actually do this. And with the technology that's being developed right now, it's actually maybe within reach.
Wow. Okay, so before we get too far ahead of ourselves, can you just give us like a little telescope 101?
Yeah.
Why is a bigger telescope better?
Okay, so basically it all boils down to light, right?
Okay.
So imagine you're trying to catch raindrops, but in a bucket.
Okay.
A bigger bucket is going to catch more rain, right?
Makes sense.
Telescopes work kind of the same way, but instead of rain, they're collecting light
Oh, okay.
from stars, galaxies, all that good cosmic stuff.
I see.
And the bigger the mirror, the more light you can gather. And that means we can see fainter objects, things that are incredibly far away.
Which is really important when we're talking about like exoplanets, right?
Right, exactly.
These are the planets outside of our solar system.
Yeah, they're so far away and so dim, they're
Yeah.
really hard to see.
Yeah.
And the problem is here on Earth, our atmosphere is kind of like trying to look through a hazy window.
Yeah.
It distorts the light no matter how big we build our telescopes here on the ground.
Ah, I see. So we just put them in space then, right? Problem solved.
Well, not so fast.
Oh.
Even with space telescopes like Hubble and James Webb, we're still limited by what we can physically launch into space.
That makes sense.
The James Webb telescope with its 6.5-meter mirror had to be folded up
Wow.
like a piece of origami just to fit in the rocket, and even then it barely fit.
Oh, why?
And the cost of launching something that complex is astronomical.
Literally astronomical.
Literally astronomical.
Okay, so we can't build these infinitely large telescopes on Earth.
All right.
But what about like in space? Like what if
Yeah.
we could just build it out there?
Yeah,
I'm guessing this is where SpaceX's Starship comes in.
you got it.
Okay.
Starship, with its massive cargo capacity and its much lower launch costs, could totally change the game.
Yeah.
Like, imagine just launching telescope parts like Legos and then assembling them in space.
Wow.
That's what Hanwar is proposing.
Now that's thinking outside the box or outside the atmosphere, I guess.
Literally, yeah.
Yeah, wow. Okay, so I'm really trying to picture this. We're launching all these telescope parts into space like it's some kind of cosmic Lego set.
Yeah.
But what happens then? How do we actually like build a kilometer-wide telescope in space?
It's actually pretty mind-blowing when you think about it.
Yeah.
So Hanmer's idea for this monster scope, this kilometer-wide telescope,
Right.
it involves thousands of these smaller hexagonal mirrors,
Oh.
each about the size of a bus.
Wow.
And they're all launched individually.
Hold on, wait a second.
Yeah.
Bus-sized mirrors.
Yeah.
How many buses are we even talking about here?
Thousands.
Thousands of buses flying around in space.
Thousands. Yeah, but here's the really cool part.
Okay.
They're actually designed to basically assemble themselves in space.
What?
Using this technology called interferometry,
Okay.
where basically all these smaller mirrors work together
Okay.
to act like one giant mirror.
So it's not just like one big dish. It's like a whole swarm of mirrors all working together.
Exactly.
Okay. Now you're really making my brain sweat trying to imagine this.
I know, it's a lot.
How does that even actually work then?
So think about it this way. Imagine you're shining like a flashlight through a bunch of tiny little holes.
Okay.
Each hole is going to project like a small little spot of light, right?
Yeah.
But when you bring all those spots together
Okay.
in the right way, they combine to create this single, much brighter image.
Oh, okay.
And that's kind of what the monster scope's mirrors would do, but with starlight.
Oh, wow.
Each one would capture a tiny piece of the light,
Right.
and then sophisticated software would combine those pieces into one ultra sharp image.
Wow, that's incredible. And this isn't just like some sci-fi dream, right? Like
Yeah.
this interferometry thing, is that a real technology?
It is a real technology.
Oh,
We're already using it here on Earth with telescopes, like the Very Large Telescope in Chile.
Oh, really?
Yeah, so each of those telescopes can work independently,
Okay.
or they can combine their light to get an even greater resolution.
I see.
So the monster scope would basically be taking that same concept,
Okay.
but to a whole new level.
Okay, so let's say, like, hypothetically, we
Yeah.
figure out how to launch all these mirrors,
Right.
get them to space, have them, like, play cosmic Lego and assemble themselves into this monster scope.
Yeah.
What could we actually do with a telescope that powerful?
That is the really exciting part.
Yeah.
With the monster scope, we wouldn't just be seeing like these points of light anymore.
Right.
Imagine being able to zoom in on those exoplanets,
Okay.
like really zoom in
Okay.
those alien worlds that are orbiting other stars. We could actually see continents,
Wait.
oceans, maybe even cloud formations on these planets.
Hold on. You're saying we could actually see, like, surface details on planets that are light years away?
Yeah.
Like, if there were aliens out there building their own giant telescopes, we could spot them.
Theoretically, yes.
Wow.
We're talking about being able to like resolve features on a planet's surface that are just a few hundred kilometers across.
Oh, my God.
So imagine looking at Earth and being able to make out like individual cities.
Okay, you know how you said this would revolutionize astronomy?
Yeah.
I think you were underselling it a little bit.
Just a tad.
This is
Yeah.
next level mind-blowing.
Yeah.
What else could we learn?
So imagine being able to analyze the light that's coming from these planets
Right.
and looking for these signatures of things like water vapor, oxygen, methane,
Okay.
the kinds of things that could indicate the presence of life.
So this telescope, this monster scope, could actually answer one of humanity's, like, oldest questions.
It's possible.
Are we alone in the universe?
That's the big one,
Now,
Mark.
that's a key takeaway.
For sure.
Wow.
And it's really just scratching the surface.
Really?
We could study the atmospheres of these planets in incredible detail, learn about their weather patterns, their climates.
Wow.
It would be like having a front row seat to these alien worlds.
This is seriously blowing my mind.
It's pretty wild.
And we haven't even talked about, like, what this could mean for exploring, like, beyond our own galaxy.
Exactly.
Like, think about it.
Right.
This telescope would be powerful enough to study individual stars in distant galaxies.
Oh, yeah.
Like, observe the birth and death of stars in crazy detail.
Unprecedented detail.
We could even potentially see back to, like, the very early universe, just a few 100 million years after the Big Bang.
Yeah, that's the holy grail right there.
Wow, just wow. I mean, this is almost too much to process a telescope that can show us alien cities, unravel the mysteries of the Big Bang expert speaker. It's a lot. It sounds like something straight out of Star Trek.
Yeah, it does a little bit.
But as cool as all of this sounds, we kind of have to talk about the elephant in the room, or should I say, like, the monster in space. Building something like this, even with Starship, has got to be insanely expensive and challenging.
Oh, absolutely. It's a massive undertaking, no doubt about it. But here's the thing. Hanmar argues that if we can use those same technologies that make Starship cheaper and reusable,
Okay.
and if we go with this whole modular approach,
Right.
he thinks the cost could actually be surprisingly manageable. He estimates something like $10 billion for the entire project.
Wait, hold on. $10 billion.
Yeah.
That's less than what some countries spend on defense in a single year.
It's true. And just think about the return on investment here.
Okay, yeah.
I mean, we're talking about potentially like rewriting textbooks, inspiring a whole new generation of scientists.
Yeah.
Maybe even fundamentally changing how we understand humanity's place in the cosmos.
It really does make you think, you know, if we can put our minds to this, what else could we achieve?
Exactly. And Hanmer points out something else that's really important. A project this big, it would have to be a global collaboration.
Oh, yeah, that's a really good point.
It wouldn't just be a win for science. It could be something that really brings humanity together.
Right.
Imagine countries all over the world coming together, pooling their resources, expertise to build this amazing tool that would benefit all of humankind.
That's a powerful thought. It's almost like this monster scope itself becomes a symbol of what we can do when we work together towards a common goal.
Absolutely. It's like this reminder that the biggest challenges, the ones that seem impossible, those are often the ones that are most worth tackling.
So to sum it all up,
Yeah.
we've got this idea for a space telescope that's so unbelievably ambitious,
Yeah.
so out there that it could actually show us alien cities, help us unravel the mysteries of the Big Bang, and maybe even bring humanity a little bit closer together.
All thanks to some really clever engineering, a whole lot of mirrors, and that drive to explore the universe around us.
Yeah.
It makes you wonder what else is out there, what other incredible discoveries are waiting for us just beyond the horizon.
It really does. And for anyone listening, we'd love to hear your thoughts. If you could point the monster scope anywhere in the universe, where would it be? Let us know. This has been an incredible deep dive. Thanks for joining us. And until next time, keep looking up.